What's up, nerds? Let's solve some quadratic equations. So, in order to solve quadratic equations, we're finding the solutions, and it's really important that you understand almost a little shortcut we can use with graphing to find solutions, and that is recognizing that the word solutions means the same thing as x-intercepts, roots, and zeros. Okay, and the most useful for us right now is that solutions are the same thing as the x-intercepts of a graph. So if we can see the graph and we can see those zeros or x-intercepts, then we know the solutions. Okay, so state the number of solutions that each graph has. So that's just really asking how many x-intercepts does this graph have? And hopefully you can speed right through things. On A, we can see in fact that there is just one x-intercept. On B, we see 1, 2 x-intercepts, those red dots, right? Those are what I'm talking about when I talk about x-intercepts. C, ooh, it does not touch that x-axis at all. There is a y-intercept, but solutions are not the same thing as y-intercepts. So this one, in fact, has no solutions, none. And D has just one. Right, so nice little warm-up problem there. Okay, let's break out your graphing calculator and see if you can find the solutions to these quadratic equations. These are nice quadratic equations where you can easily tell if you're on that standard zoom, they have whole number zeros or whole number x-intercepts. So go ahead and graph A, and you should see a downward facing parabola, and it's going to look a lot like D, where it just has a single x-intercept. So that's going to be at -5, 0. And it's the only one, so I'm going to go ahead and leave this guy blank. The domain of this is from -infinity to infinity. Okay, the range, since it is downward facing, goes down forever, but it only goes up to 0 and does include 0, so we use a bracket there. Alrighty, so go ahead and take the time, pause, graph B, make sure that you can do that quickly and efficiently. You should see 2 zeros pop up. You have a 0 at 2 and a 0 at 4. Alrighty, the domain for all quadratics is always -infinity to infinity. This one's an upward facing parabola, and we can see that the bottom of it, or that minimum value, is -1. So the range goes from -1 to infinity. Alrighty, again an upward facing parabola, which when we graph that actually has no zeros. That's interesting. That domain's still -infinity to infinity, and that range, since it's upward facing, has a minimum. The minimum value is 3, but then it goes up forever. Alrighty, some good practice with our calculator. Now let's do something extra fun. We need to be able to find non-whole number, non-integer zeros. So we can do that by using the calculate menu in your graphing calculator. So this is going to be the same place where we can find maximums and minimums, and it can tell me non-integer vertex values. We just have to go through those same questions. We have to tell the calculator where to look by telling it how far left should it look, how far right should it look, and then to guess right in the middle as close as we can there. Okay, so I went ahead and already did this for you. Please do not just copy these down. We need to make sure that you can do this on your own, and the more you practice, the faster you're gonna get at it, and the more likely you are to remember how to do it. So please go through and graph A, find both of these zeros and verify that when we round to the nearest hundredth, you get -2.41 and 0.41. And I'm going to give you a little caveat. I did these quickly. I very well could have made a mistake. So if you double check everything and you think I've messed up, feel free to come ask me because I am not too proud to own my mistakes when I make them. But I'm pretty confident. These are the two zeros here for this problem. And now we need to answer the questions. Where is this function positive and where is this function negative? So I'm going to draw a bad graph real quick. I know it's downward facing. I know that there's a 0 at -2. There's a 0 at 0.41. So your graph looks something like this. And we need to say, where is this function positive and where is this function negative? Okay, so I'm going to start with the positive values. So remember, positive is just referring to the y values. So it's this section of graph that's positive, which is going to be along this interval of x values. Okay, so I know that between those two zeros is going to be -2.41 to 0.41. Okay, and I know that this can be confusing because these two answers here are an ordered pair. Right? This is an x value and a y value. It is the location of an x-intercept. Okay? For positive and negative, these two are going to be an interval. And especially when I use parentheses, they look exactly the same. It's kind of hard to tell, so that's why context is so important. I know that both of these are x values, and I'm saying it's an interval between these two x values. And even though it looks like an ordered pair, because I know the question is positive interval and negative interval, I know that this is an interval, and I know that the zeros are talking about an x coordinate and a y coordinate, or they're an ordered pair. Okay, so let's go ahead and look then at negative. So the function's negative here. That's where all the y values are negative, which is talking about all of these x values. So again, I'm going to write an interval. That's going to be when x goes from -infinity up until that first 0, as well as starting at 0.41 all the way to positive infinity. Alrighty, so more practice of the same. Again, please do not just copy down my answers. I need you to practice graphing these in the calculator and finding the zeros on your own. So for B, here's my zeros. It's upward facing, so it looks a little bit something like this. So my positive intervals are going to be the two ends. That's where the y values are positive, which is going to match these x values. Okay, so that's going to be from -infinity up until that first 0. And then from that second 0 up to positive infinity. Okay, and then I am negative right in the middle there, so that's going to be those x values in the middle. So that's going to be from -0.54 to positive 1.87. And example C, we have a downward facing parabola. Once you get that graphed, should look a little something like this. I am positive in the middle, so that is the x values between the two zeros. And I am negative on either side of that, so that is going to be from -infinity to my first 0, and from my second 0 out to infinity. Alrighty. Let's move on to the back now. So what happens when we don't have a graphing calculator? What happens when we have to solve? by taking the I can solve algebraically. One of the ways that I can do that is by taking the square root of both sides. So, we're going to learn a lot of different methods in this chapter for solving, but this kind of practices what we reviewed yesterday. So, solving by square roots. We first need to start by isolating the x squared term by following the order of operations. And remember that when I'm undoing operations, I need to do that order of operations backwards. So we're going to undo order of operations. Ooh. All right, so undo that order. That just stands for order of operations. I just don't want to waste your time writing it out. So undo order of operations backwards. Which means I need to get rid of addition and subtraction first before I move any multiplication or division. Okay, so in example A here, to isolate that x squared term, I need to start by moving the subtraction first. And we are going to get 2x squared equals 56. Okay, then I can divide both sides by 2 now. We get x squared equals 28. Okay, now it is time to take the square root of both sides, but we need to make sure, since we are introducing the square root, we're saying that something squared equals 28. It could be a positive squared or it could be a negative squared. So I need to include that plus or minus of both sides. That's going to leave me with x equals positive or negative. And I know I'm going to have to simplify this, so I'm going to go ahead and start with two separate square roots. 28 is the same thing as 4 times 7. So we end up with positive or negative 2 root 7. Alrighty. Let's do another one. Maybe try pausing, see if you get the same answer by yourself. Save you some time, and maybe you don't have to listen to me the whole time. What a delight. Okay, divide both sides by 4. Take the positive or negative square root of both sides. Which, interestingly enough, at this point in our career, we cannot, well, it'd sure help if I copied down that negative, right? So that was almost a silly mistake. -1, I should have written a -1 right there. Okay, so caught my mistake, I put that negative there. But at this point in our math career, we cannot simplify the square root of -1. If you tried typing this in your calculator without the plus or minus sign, there's no plus or minus in your calculator, you end up with an error that tells you that there's no real solution. So that's what we're going to write when this happens right now. We're going to write no real solution. We are not going to write no solution because there actually is a solution. It is just not a real number. And we're going to talk about that very soon. Uh-oh. Boop, there we go. Okay, so, and that is an important distinction that I want you to make. Please don't write no solution. It's no real solution. Okay, C, again, maybe you can actually solve this one on your own. So, I'm going to multiply both sides by 4/3 because 4/3 times 3/4 equals 1. And I know that multiplying by 1 is just going to make that coefficient go away essentially. So I need to multiply this side by 4/3. And yes, this is something I would expect you to be able to do without a calculator, so it might be good to practice. Okay, notice normally I would say like we have to get rid of the plus 1, but it's inside parentheses, right? The parentheses are almost protecting what's inside of it, and we need to get rid of this squared first. Oh, well, not that way. There we go. Okay, so at this point, I'm going to go ahead and take the plus or minus square root of both sides. That square root and the squared are going to cancel each other out. So I'm just left with the x plus 1 on this left-hand side, and plus or minus the square root of 40 over the square root of 3, which I'm going to go ahead and take a second right now to rationalize that denominator. Remember, that's math etiquette and something we just need to do. So I'm going to multiply by my creative version of 1 in order to leave this expression equivalent, but get rid of the radical in the denominator. Okay, and I'm going to do some side work here. So we're going to end up with the square root of 120 over the square root of 9. Okay, and the square root of 120 is going to be, I think 4 is the biggest square that goes into it. 4 times 30? I don't think 30 has any perfect squares. 2 times 15, yeah. Over 3. Okay, so now I know how that square root simplifies. Okay, so I have x plus 1 equals, don't forget that positive or negative 2 root 30 over 3. Okay, and then I can subtract 1 from both sides, and it's just a good habit to get in. You can put a minus 1 over out to the right, but typically when we have the plus or minus, we're going to format our answer as x equals negative 1 plus or minus 2 root 30 over 3. And that's kind of the most standard way to write that. And there are other equivalent ways to write this, but I'm fine with this for now. Okay, something that is important for you to recognize about this is that this is actually 2 solutions, right? In order to figure out what this equals in our calculator, we have to type it in 2 separate times. We would have to type in negative 1 plus 2 times the square root of 30 over 3, and then retype it in again and say negative 1 minus 2 square root 30 over 3, right? So I have 2 different zeros. They're not very pretty, they're irrational, but I do have 2 different zeros. Okay, so another way to solve is remembering that solutions is the same thing as zeros. And so a way that we can solve is by setting a function equal to 0 and solving it, right? And that's where it is so important that we know our vocabulary. Flipping back to the first page, right? We have 3 separate terms for solutions. It could be x-intercepts, it could be roots, which is what we were just doing. We were doing the square root of both sides. Or they can be called zeros. So let's explore why it gets that third name. Okay, so find the solutions, and I'm going to do that by setting the equation equal to 0. Okie dokie. So then I can add 80 to both sides. Divide both sides by 4. Take the plus or minus square root of both sides. I'm going to split that up because I know I can simplify it. And so these are my zeros, or my solutions, or, and this is a great connection, these are the x value of the x-intercepts. Because we know that x-intercepts are the same word, or really same vocabulary as solutions and zeros. Right? So these are all really, really, really important things for us to know. And I know I say that pretty much about everything, but everything in Algebra 2 is so important. Go crazy. Okay, let's look at B. So again, we're finding the solutions without having to graph. We can do that algebraically by setting the equation equal to 0. Okay, notice something that I am not doing. I am not just setting the whole line equal to 0. And that's going to be an important habit that you don't get into when we're taking AP tests in future courses. So I really want you to write it as a separate line because I do that every single time. Subtract 9 from both sides, divide both sides by 3, take the positive or negative square root of both sides, and again we see that we end up with the square root of a negative number, which your calculator is going to give you an error for. So you need to remember the way to phrase that is there are no real solutions. Because there are solutions, they are just not real numbers. So we just want to make sure we're using good, precise vocabulary. Alrighty, example C. Ooh, a lot going on, but we can do it. Finding the solutions, so I'm going to set this equal to 0. Add 5 to both sides would be my first step. Multiply everything by the reciprocal in front there, so I'm going to multiply everything by 2/5, and that's going to go here and cancel out, and to this side of the equation as well. Okay, plus or minus square root of both sides. And in a super exciting turn of events, we don't have to simplify this. Subtract 3 from both sides. And we do have 2 separate x-intercepts. We have an x-intercept at -3 plus square root 2 as the x value. And we also have an x-intercept at -3 minus square root 2 as another x value. Alrighty, and the last way that we can solve still is dealing with zeros, but what happens when I can't easily solve by taking the square root of both sides? And that's going to happen when we have just a plain x term in the middle. It's not an x squared, so I can see a couple of those here. In order to do that, we're going to have to factor. So let's go ahead and jump into that, and then I'll talk about this zero product property, because that is really important that you understand. So we know we want to solve this by finding the zeros, which means we want to move everything to one side so that the equation equals 0. Okay, we can practice factoring, which is why we reviewed it in 3.0. Okay, looking at that first term, it's just a plain old x, which I know comes from these two, so x and x. Okay, and then -45. And remember, I just need to think of factors of -45 that are going to subtract to 4. So 1 and 45 doesn't work, 2 doesn't go into 45, 3 and 15. 4 doesn't go into 45, 5 and 9, looks like I found it. Okay, so this one I don't have to worry about anything with the x multiplying because it's just one x on both of them. So I know that one of my values is 5, one of my values is 9, and we want the sum to be -4, which means the 9 has to be negative. -9 plus 5 is -4. Okay, and now that I have all that, the zero product property says that if I am multiplying two things together, and in this case I am multiplying this parentheses times this parentheses, in order for two things multiplied to equal 0, it either has to be 0 times anything in the world, right? Because 0 times anything is going to be 0. So either this first parentheses has to equal 0, or this second parentheses has to equal 0. So if I set each parentheses equal to 0, that is me using the zero product property, and then I can go ahead and solve for my values of x. Subtract 5 from both sides, and add 9 to both sides. So we have already talked about the fact that this is really putting a quadratic into what we would consider factored form, also called intercept form. And we know that those intercepts always have the opposite value, right? So I'm talking about the form of a quadratic that looks like this. A times x minus m times x minus n, right? We talked about that in chapter 2. We know that m and n have opposite signs in the equation as they do, or as their corresponding zero values do. And this is the reason why. It's because of the zero product property in action. Okay, so maybe try b on your own. Remember, we want to move everything over to one side. So I'm going to subtract 2x from both sides, combine like terms. I'm also going to add 12 to both sides and rewrite. Okay, I want a factor. Okay, 2x has to come from these two, which I don't have a choice. Love it when that happens. Okay, and remember here we're looking for factors of 24 that are going to combine to 11 or -11. So 1 and 24, 2 and 12, close but no, 3 and 8, that looks like our winner. Okay, so how do I get 3 and 8? Well, 2 times nothing's going to be 3, but 2 times 4 is 8, and then 3. And I can double check and just make sure that 12 is in fact 3 times 4, looking good. And the only way for them to combine to be negative is if both of the factors are negative, and -3 times -4 is +12. Okay, so then I can go ahead and use that zero product property that says if two things multiplied equal 0, one of them has to be 0. So it's either 2x minus 3 or x minus 4. Okay, so 2x equals +3. X is either 3/2 or +4. Alrighty, ACT practice for free. What is one of the solutions to the given equation? So this is an interesting SAT problem where it's a free response and there are actually 2 acceptable answers. You can do this quickly by graphing and looking at the zeros. I have absolutely no problem with that. Honestly, for me though, it is faster for me to factor this than it is for me to graph. Except for the fact that this is not correct. 6 times 4 is 24, and 6 plus 4 is 10. but I have the signs wrong. That just isn't going to work. So we need to be careful when we're factoring. 12 and 2 actually also combine to 10, and it needs to be positive. Okay, this is looking better, right? Factoring is only as smart as the user. Negative 12. C equals 2. So you could put either of these answers for the ACT. You could either put negative 12 or you could put 2. There's no way for you to put both, so it's just looking for one of them. You can verify that that is the correct answer by graphing. Alrighty, number 2. How many real solutions does the following equation have? Again, this is a great one for you to do by graphing. If you graph this, then you should see that the graph is going to look something like this, which you can very quickly tell has absolutely no solutions. Alrighty, have fun working on that 3.1 practice, and I will see